Hi, this is Joel Duff, and today we begin what I believe will become a series called the Hemoglobin Challenge. In that, I hope to gently nudge some young Earth creationists to correct their soft tissue fossil fibs. So in this video, I need to introduce you to the main player, hemoglobin, and we need to talk about a little bit of the history of what I call the problem with how hemoglobin is portrayed in young Earth creationist literature and in young Earth creationist speakers' presentations. So that's going to introduce you to some of the participants in the hemoglobin challenge. And then we'll end with our very first participant, who will be Matt Powell. So the Hemoglobin Challenge, episode number 1, coming up. All right, before we get talking about this Hemoglobin Challenge, we have to talk about the most important player in this whole drama, which is the molecule itself, hemoglobin. Hemoglobin is a complex macromolecule found in animal blood that's responsible for the transport of oxygen. So a really important molecule. And you have a whole lot of it. Each red blood cell in your body, so let's talk about human beings here first. Each red blood cell in your body has about 270 million of these hemoglobin molecules. And each hemoglobin molecule consists of about 11,200 individual atoms, hydrogens, carbons, oxygens, nitrogen, a little bit of sulfur, and as you'll see, iron. 10,900 of those atoms are found in the globin part, right? So there's 4 separate globin proteins, 2 alpha units and 2 beta units, and these 4 different proteins then come together into this large quaternary structure, it's called, that forms the globin part of the hemoglobin. I keep saying globin, but it's just globin, I guess. The funny little blue and red spiral things just are a cartoon depiction of these 11,000 atoms, right? Because it's an awful lot of atoms. So they fold up into 3-dimensional structures. And again, those 3-dimensional protein structures then bind to each other to form this globin protein. Embedded in this globin macromolecule are these 4 heme units. And so that's what's shown in here, embedded inside of this protein. And so you have this heme molecule, which itself is, if you put the 4 together, about 300 atoms. Hydrogens, carbons, oxygens, and you'll see here there are 4 nitrogens here in the center. And then there's an iron right at the very center of this molecule, and that's what's attracting the oxygen molecule. All right, so you have these 4 units that are embedded in the globin. So you put that all together and you have hemoglobin. And just think about the countless numbers of hemoglobin molecules you have in you right now. If one individual red blood cell has 270 million of these macromolecules, and you have some 20 to 25 trillion red blood cells in an adult human being, that's 25 trillion times 270 million. That'll give you an idea of how many hemoglobin molecules you have, times 4 to get the number of heme units. That's how much oxygen you can carry, all right, in your blood. That's an awful lot, right? That's an enormous number of total atoms dedicated to just this one thing in your body. All right, so that's hemoglobin. And that is going to be part of the Hemoglobin Challenge. So what's this Hemoglobin Challenge? It's about how some individuals describe the discovery of red blood cells and macromolecules or organic molecules in fossil remains. So for example, looking at this particular fossil here of a mosquito. This mosquito is thought to be somewhere between maybe 12 and 15 billion years old. And here are a couple headlines from this recent story of this fossil find. Is there fossils full of blood? Well, here's the title here's the popular reporting in some of the creationist journals. Unprecedented blood-filled mosquito fossil raises questions over evolutionary dating methods. The implication being, if there's blood in this fossil, right, and you're saying the fossil is supposed to be millions of years old, how could that blood have survived, right? That's an organic molecule, shouldn't have decayed over that period of time. Second headline here, bloody mosquito fossil supports recent creation. The same idea, right, from Institutes for Creation Research, ICR. How could this do anything but support a young Earth if there's blood found in this particular fossil? Answers in Genesis. First fossil mosquito found filled with blood. All right, now when you read headlines like that, or when you hear a younger creationist on a video or at a conference giving a talk, and they start talking about how there's been blood found in dinosaur bones, or in this particular mosquito, or some other millions of year old fossil, what does the audience think that the speaker is saying? They think that there's blood found in these fossils. And in particular, we're going to ask the question, is there hemoglobin found in these particular fossils? So maybe the best illustration of this, and this is what I'm challenging, comes from we'll call it a YouTube young Earth creationist, a Kent Hovind wannabe. And he has a video. This particular video is from just about a month ago. Best proof that dinosaurs lived in the recent past. So what does he think is the very best proof that dinosaurs are not old, but must have lived recently with human beings? Here's a portion of the transcript from his video. You see, dinosaurs lived with man. The Bible says, "Behold now the behemoth which I made thee." Man and dinosaur coexisted together, and the reason we know that this is because bioorganic evidence does not lie. We find collagen inside of dinosaur bones. We find blood vessels, blood cells. Here it comes. Hemoglobin still in the blood cells. We find FEX proteins, histones. We find skin pigments. I mean, look at all these things. They would have biodegraded over the deep time of millions of years if evolution weren't even true. But that's why evolution is not true. It is false. Creationism and creation science is what has made testable predictions. And we would be able to predict that if dinosaurs lived recently, we would still find organic materials inside the bones. Right? So if dinosaurs had died recently, there should still be some remains of organic materials. But if dinosaurs are millions of years old, there shouldn't be any organic material left. But look what we find. We find hemoglobin, we find blood cells, we find blood vessels, we find collagen and so forth. And hence, dinosaurs are young. Now, but what exactly was found in these fossils? All right. So hemoglobin, what has been observed? What has actually been preserved in this mosquito or older fossils such as dinosaurs? I'm going to say that from my reading of the literature, that what has been found are hemoglobin-derived porphyrins, to be precise, but I'm going to show you what those are in a moment, or chemical breakdown products of hemoglobin, right? They are the end result of a chain reaction of decay that results in a product that we then identify as the breakdown products of hemoglobin. Or you could say they're the evidence of the former presence of hemoglobin, right? There's something that's in the fossil that tells you hemoglobin was here sometime in the past. But the actual hemoglobin molecule isn't present. Possibly some of the atoms from that hemoglobin molecule are still there, but they're not in the state that they were when it actually was hemoglobin. Now, if you look back at that quote, you would understand that the audience doesn't perceive any of what I just said, right? They hear blood cells, red blood cells, they hear hemoglobin, and they just think, oh, those proteins are found. Those cells are found, just like if it had died yesterday and there's the blood spilling out. All right, so let's go and let's look at, before we get to our challenge and what I expect from the players in this challenge. What do I mean when I say that the hemoglobin that's in dinosaur bones or in this mosquito that's millions of years old is not actually hemoglobin? It's hemoglobin-derived porphyrin. And that comes for this particular example, this comes from a PNAS paper recently. Hemoglobin-derived porphyrins preserved in a Middle Eocene blood-engorged mosquito. Now, they use the words blood-engorged mosquito. All right, so even the title of this paper mentions that. But if you read through the scientific article, what you realize is what they're saying is there's evidence that hemoglobin was present here. And therefore, the abdomen of this individual mosquito we see in the fossil record at one time was full of blood. They're not actually claiming that there's blood in the abdomen. They're claiming that there is the remains of one of the molecules that's found in blood that's a breakdown product of that, which provides us with strong evidence to infer that blood once existed here. Now, that was a whole lot of words, right? And that's hard for maybe a speaker to spit out. It was hard for me to spit out. But it's actually far more accurate. It represents what was actually found, and it communicates to the audience, hopefully it communicates to you, that it's a false equivalence. If you just say blood, red blood cell, and hemoglobin, you say that's what was found. That will give the false impression that it's the same thing that's present today. But in fact, it's very different, all right? So it's undergone an immense amount of chemical modification. And that modification suggests a long period of time, right, has occurred in order to create this chain of events that leads to this degraded product. All right, oh, by the way, this particular paper has to do with that mosquito that I showed you earlier. And the headlines from Creationist about this particular research, that's what I read to you earlier. If you read this PNAS paper, you wouldn't come away with the same impression that they have given you with their sort of clickbait titles, but they're not going to really expect their audience to actually have read the PNAS paper. In fact, I'm a little suspicious that most of them haven't read the PNAS paper, this peer-reviewed paper. They've probably just looked at sort of popular press articles, which do use clickbaity titles that use the word like blood-engorged mosquito, but without explaining what was actually found. All right, so there's a great figure in another, a short, a highlight paper, I guess you could call it, from PNAS by Derek Briggs, a very famous paleontologist, who took a look at this paper and then he wrote a common summary. And so again, creationists should look at that basic summary. It has this fantastic figure in it, and it shows you what that paper is saying. It's saying it's not blood cells that were found there, but altered remains of a particular biomolecule that once was present inside the abdomen. So here we have our mosquito, right? And a mosquito, if it's recently had a blood draw, is going to have an abdomen that's full of blood. And that blood, as we saw, each blood cell potentially would have millions of hemoglobin molecules. And so the hemoglobin molecule is the protein. And then you have the heme units embedded in there. So here's our heme unit again. And then what has happened in the fossilization process? Right? So what do they actually see in this particular fossil? What they find is that there was protein decay. How much protein decay? Complete protein decay. So all this faded out region here is the part that's missing. It's not present in the abdomen of this mosquito. That's all the amino acids, all right, of the proteins. Right? So those 4 subunits, they're completely decayed away and gone. And what's left are the heme units, but the heme units are also altered, right? They've been chemically degraded themselves. And so you'll see that some of these side chains have come off, and it forms this cyclical compound, all right, with a whole bunch of carbon double bonds, nitrogens, and then you have the iron in the center. And this heme unit, all right, is a type of porphyrin, all right? It's a class of organic compounds. So this is an organic compound. There's carbon, there's hydrogen, and there's nitrogen, and there's iron here. But the carbon and the hydrogen is the big thing, right? This is an ultra-stable molecule. Once it reaches this point, right, this becomes incredibly stable, and one doesn't expect it really to degrade very much in any kind of protected environment. it's probably going to remain and potentially could remain for millions, tens of millions, potentially hundreds of millions of years. It could remain in this particular form. After all, porphyrins are found very frequently in oil formations, right? So mixed into the oil are often these porphyrin type of molecules, not necessarily with the iron inside, but nonetheless the basic structure you're seeing here. And, and that's been known for a long time. So that's a biomolecule, right? And that's a biomolecule that is said to have been preserved for hundreds of millions of years in many cases. And so that's not ever been a surprise to any, to any paleontologist or really any geologist or geophysicist. They're not going to say that they're surprised to see these kind of molecules preserved over long periods of time. These aren't expected to decay. What is expected to decay fairly quickly are the amino acids, all right, that are what compose the proteins. And in fact, that is what's gone. There's very little to zero amino acid in this particular case. There are some biomolecules like collagen, which is composed of repetitive amino acids, which can get to a state of being protected and preserved. They're still decayed in the sense it's kind of like this heme unit, right? It'll have side chains that have been lost. The amino acids themselves have been manipulated. They've been reconfigured at a molecular level, but you can still look at them and say, oh yeah, I can see how this molecule is just a shape-shifted version, right, of a prior molecule, a prior amino acid. And so we can look at some of those molecules in the fossil record and say, yeah, I can see that those were originally these particular amino acids. But they're not what they were in the original state. It would be wrong to say that, Matt Powell in that quote there just talked about how there's collagen, there's blood vessels, blood vessels are composed of very fragile, he's right, a variety of different structural proteins and phospholipids and other things. And those really aren't present anymore in that particular state. Okay, so what I've established here is, and I guess the whole point of this is, when individuals come out and they say, oh, look, they found hemoglobin, they found red blood cells, you need to ask, what do they actually mean was really found at these sites? What is the molecular characteristics of these molecules? Are they the same as present-day molecules, or have they undergone an enormous transition into a more stable molecule? And that's what's happened here with hemoglobin. There is no hemoglobin because the globins are gone. It's just heme that's present. So I'm asking for accuracy in reporting. What's been found is not hemoglobin. What's been found is the possible presence of hemoglobin in the past, right? A bioindicator that hemoglobin once was there. All right, let's do a little application of this because I want to explore where might we find hemoglobin and where don't we find hemoglobin. Because in my challenge, I'm going to want young Earth creationists to express these differences, and I want them to acknowledge these particular differences of timing. So dinosaurs, right? So if you look at a number of different dinosaurs for which soft tissue has been reported to be found. And there's the same kind of problems with soft tissue. When somebody says soft tissue, that's something that conjures up an image in one's mind of what soft tissue would be, which often isn't exactly what's described in the literature. But we're just sticking with hemoglobin here. We're going to try to keep the story simple and the challenge simple. We're just dealing with hemoglobin. So in the case of dinosaurs, let's say they're 65 to maybe 200 million years old by conventional radiometric dating. Now, for the young Earth creationist, they think they're only 4,350 years old, right? That's the approximate date of Noah's flood. And so every single dinosaur in the fossil record are really exactly the same age, right? Within a year, all right? They're all within a year, every single one of them, because all of them preserved in the flood, all were alive at the same moment in time and then pretty much died within 9 months of each other. What do we find in those? We find tiny amounts of modified heme molecules. right? That's the language that I want to hear. Small amounts of modified heme molecules. Remember, the blood that was originally in the bones, there would have been millions and billions of red blood cells, and then they each would have contained millions of hemoglobin molecules. What's found now is some considerably smaller portion of that. All right, a very small fraction of that amount of material that would have been there. And what is found is extremely modified. All right, so that's why I'm saying tiny or trace amounts of heme molecules. There's also possibly modified remains of portions of blood cells. So there are components of blood cells, of which hemoglobin is one, which are chemically modified and are still in the same position where that red blood cell was. And so we might have the outline of a red blood cell, or actually portions that have been replaced by other molecules or chemically modified, and so have the appearance of red blood cells. But they're not necessarily red blood cells, right? If they were red blood cells, we'd be able to extract phospholipids from them and all kinds of different chemicals from them, easily be able to do various chemical tests and identify the specific biomolecules. That's in dinosaurs. Now, I threw in the mosquito for a reason. This mosquito is much younger. It's only 10 to 15 million years old, right? It's a youngster on the geological column. For young Earth creationists, it must be, say, 3,500 to 4,300 years old, maybe even 4,350 years old, right? Sometime very soon after Noah's flood. And the reason I say that is because they're found in post-flood sediments. Well, all right, depends on which creationists you talk to. Some creationists think that this fossil was found in flood sediments, in which case this fossil also would be 4,350 years old. Now, what's found in that mosquito? I already showed you. Tiny amounts of modified heme molecules. All right, so even the heme that's left is modified and not exactly the same as it would be in the original hemoglobin molecule. But it is evidence that hemoglobin was there in the past. Right? It's the smoking gun evidence, I guess you could say, that hemoglobin was present. And there aren't any visible red blood cells or any structures that look like red blood cells, right? So everything else is gone, after 10 to 15 million years. Mammoths. Now let's compare that to mammoths. All right. So conventionally, 10 to 1,000 to 100,000 years old are some of the mammoths that we have found that are in pretty decent shape up in the permafrost in the northern hemisphere. And of course, for young Earth creationists, mammoths departed the ark and then moved to the north, and then eventually got trapped in ice age, a situation just a few hundred years after the global flood. So they're somewhere like 3,500 to 4,300 years old. In other words, they're about the same age as that mosquito. And yet, when we crack open a mammoth leg, or actually tissues are even preserved, real tissues, and I'm going to say they're actually soft tissues. It's like they actually have cells in them. They have cells with massive amounts of organic material. But speaking to the question of hemoglobin, they have billions of red blood cells, like easily identified red blood cells, which you can extract hemoglobin from. And you can extract billions and trillions of hemoglobin molecules. And hemoglobin molecules are proteins, the entire protein, right? All the subunits are there. The heme is there, and the heme is basically unmodified. So after 10,000 to 100,000 years, we still have a lot of organic material that has yet to decay. In the young Earth creationist model, here they are about the same age as this mosquito and this dinosaur, and yet they're radically different in terms of their preservation. So part of my challenge is, and part of my complaint, and the reason for the challenge is, when this is presented to many young Earth creation audiences, words like hemoglobin, red blood cells, and so forth are thrown out as if they're the same in a dinosaur as they are in the mammoth. And they're not. It's a false equivalency. They're nothing like each other. All right, so what is the hemoglobin challenge? The hemoglobin challenge is this. Can anyone who has inappropriately said and there are many creationists have inappropriately described hemoglobin, said or implied that dinosaur bones have undecayed hemoglobin in them. And by undecayed, I mean if they just say there's hemoglobin there, they're implying it's not decayed, right? And that Matt Powell quote before actually refers to no decay having happened, right? It's been around for a million years and it hasn't decayed, right? So he is directly suggesting that hemoglobin is present and it hasn't decayed, except it's not hemoglobin. It's just heme, and it's definitely decayed, right? That if he hasn't read the paper, if he just picked that up from other literature, then I guess he's not outright lying because he's just saying what he's been told. But he should watch this video, and I will encourage others to send this video to him. And once he has heard this truth, okay, I expect that he should modify his language if he wants to tell the truth, if he wants to tell his audience factual information, all right? Describe the facts of this world as we know them. I mean, things could change in the future, but as we know them today, then he need to be more careful describing his terms so as to not give the false impression, put a false impression in his audience's ears. All right, so what I expect is this. If any particular person anyone in the creationist community has inappropriately said or implied that dinosaur bones have undecayed hemoglobin in them, I want them to recognize their error and describe this soft tissue more accurately in the future. So I want them to use terms like, and they can use their own terminology as long as it's accurate. But here's some of my suggestions. Hemoglobin-derived porphyrins. Now, that doesn't exactly roll off the tongue, and it's hard for the audience to possibly understand, so it might take a little more work to really just define what's happened there. What's the difference between this hemoglobin I'm talking about and the hemoglobin that's inside me right now? Or maybe chemical breakdown products of hemoglobin, right? So what we find in the dinosaur bones is we find chemical breakdown products of hemoglobin. So we find evidence that they had blood, and we see some breakdown products of that blood. But it's not exactly like they just died yesterday and here's their blood and full-on hemoglobin proteins. Or maybe more simply, evidence of the former presence of hemoglobin. All right, just admit that what we find in these dinosaur bones is evidence of the former existence of hemoglobin at this particular location. Now, that's not so snazzy, and I recognize that's not going to go a long way to making it sound like a really strong argument for young Earth creationism, right? I mean, Matt Powell wants to make it sound like they're a million years old, so they would have had to have decayed, but they haven't decayed, and therefore they're young. They can still make the argument that they should have decayed more than they have over millions of years, and maybe they should have broken down more than we see, but you have to admit they've broken down, that they are byproducts of a former molecule. All right, or some similar phrase capturing this sentiment, right? That's what I'm expecting. That's my challenge, is for young Earth creationists to up their game and to be more accurate about the paleontological evidence here. So who's the main players in this challenge? Who am I challenging, right? I mean, I'm challenging everybody from the, YouTube creationists out there. So Matt Powell, Kent Hovind, who's certainly made this claim hundreds and hundreds of times probably. But also mainstream young Earth creationist organizations that when they write articles about soft tissue are not careful about describing the findings and recognizing the difference between what this particular preserved biomolecule is compared to a modern biomolecule. And then, of course, there's a wide body of literature that includes that as well. Right, so how's this going to work? How's this going to work? Because this is episode number 1. And what will constitute episode 2, if I ever make an episode number 2? But I anticipate I will. And the reason I anticipate I will is because I'm looking for 2 possible responses of 3 possible responses, but 2 that I'm looking for. I will recognize and I will applaud, right, any creationist who educates themselves about the various states of hemoglobin decay and accurately reports the physical evidence found in these fossils, right? If they use the language I just gave them, and they go through a little more effort to describe, they can still make their inferences that they would like to make, but they need to describe accurately the actual condition of the fossils themselves. All right, and if they do that, I'll say, thank you very much. I really appreciate that. Big pat on the back, maybe some kind of trophy, right? Okay, the other possibility is, all right, so I potentially would come on and make a video in which I show a creationist actually using the correct terminology, and I applaud them for that, right? Nothing but good things to say. Or I will call out each time a young earth creationist repeats the claim of hemoglobin preserved in dinosaur bones without making it clear to the audience just what the condition of that molecule was found in. All right, I said this in a This Week in Creationism episode because I've already complained about this at least twice, right? I've already pointed out Powell, and the part that I just did earlier, and in an earlier episode, I noted the misuse of terminology, which is used to manipulate. I think it's very manipulative, right? Because I do think that they know they're not being accurate in their wording. In which case it's manipulating the audience to make a connection that is not an accurate connection, right? So each time I hear the repeated claim, right, that's another episode. It might be a short episode, just calling them out, saying, hey, you use that term inappropriately again. So either way, next episode of the hemoglobin challenge. Right, so either might warrant a special episode, and so watch out for future episodes. I said that we have a new player. Now, I already mentioned Matt Powell because I quoted him earlier. But what stimulated me to make this video today was that yesterday, Matt Powell released another video in which he repeated exactly the same claims that he did a month ago, repeating the same thing about soft tissues. And claimed that hemoglobin is found inside of these fossils. So now here's the quote from his latest video. We find collagen. We find blood cells with hemoglobin still in the blood. We find DNA, dinosaur DNA, and so all these things that should have deteriorated if they died out 65 plus million years ago. And so we're finding soft tissue and DNA inside of duck-billed dinosaurs. Now, we could do the DNA challenge. We could do the blood vessel challenge. We could do all these different things. Why? Because they all have the same problem. If you say there's DNA found, people are imagining a double helix, right? At best, so far, from these organisms, there is possible staining of some remnants of DNA, but that DNA might be like an adenine, a cytosine, which may both be modified, chemically modified, and maybe fused together, but maybe it still stains with our staining marker. That's not a DNA molecule, all right? That's a fragment of a DNA molecule that's highly modified. So in other words, that's decayed. The DNA is decayed, all right? And in the decay process, molecular reconfiguration takes place, in which case molecules bind in new ways to become more and more and more stable over time. And eventually they become very small molecules, like the heme molecule is tiny compared to hemoglobin. It's I think I calculated it was like 1/45th the size of hemoglobin. So 44 parts out of 45 parts of a hemoglobin are decayed away and the atoms all lost. And what's left is modified into an extremely stable structure. And so it may have decayed within the first couple thousand years, 10,000 years or 50,000 years, down to the point where it got down to the heme unit, the porphyrin. And then at that point, it just stops decaying because it's ultra stable at that point. The same thing can happen to DNA molecules, right? They're going to fall apart from a very complex structure, and they're going to break and fragment, and eventually the individual pieces, right, of the code are going to fuse together. And then, so you're going to have extreme chemical modification, and we might be able to still identify there was DNA here, right? But to say, oh, we found DNA, that makes it sound like, oh, DNA, well, that must mean they just died recently, because we know that DNA decays right away. These discoveries literally prove beyond any shadow of doubt that these creatures died recently and not millions of years ago, because organic material can only last a maximum of 10,000 years. No. I mean, organic material, there's, like what we just said, what about oil? It's like, what about melanosomes, which are very, very stable structures, and certainly can last well over 10,000 years. I mean, even theoretically last much longer than that. I mean, oil lasts millions of years, and no one's saying that, oh, oil should just disappear, right? It's a very stable structure in the locations that it's found. And as I've just shown you, the heme molecule itself, the modified heme molecule, is exceptionally stable as well, along with some other components that have been found in some of these fossils, right? They're the end result of decay, not that no decay has happened, right? Decay has happened. It has deteriorated over thousands and millions of years. Now, he says a maximum of 10,000 years. I think I know where that comes from. That only has to do with the DNA. And so he's either misquoting or misremembering or misapplying a piece of information and sort of broadly applying it to all organic molecules, which obviously is not true. Now, evolutionists go running to preservation. They think that preservation techniques are the reason for dinosaur DNA, or blood within hemoglobin and cells didn't deteriorate for millions and millions of years, right? So now here's the phrase, right? And he even added this compared to when he talked about it a month ago. Blood with hemoglobin in the cells didn't deteriorate for millions and millions of years. He believes that hemoglobin is present inside those red blood cells. And those red blood cells are like our red blood cells today. That is a complete misconstrual of the scientific evidence found to date. And he is misrepresenting that evidence, right? And if he's misrepresenting that evidence, do these discoveries literally prove beyond any shadow of doubt that these creatures died recently? If anything, my example of mammoths still having blood, right? Still having lots of hemoglobin, and they died 4,000 some years ago. They died right after the flood, right? They're like some of the oldest things you could find that would be after the flood. And they have lots of biomolecules. So biomolecules can, I mean, even by young earth creationist reckoning, have to be able to survive very, very well in many environments for at least 4,500 years. But dinosaurs and all these other fossils that are 100 million years old, by young earth creationists' own reasoning, they're only 4,500 years old. They should expect that they would have lots of biomolecules. I mean, if it can survive 10,000 years and they're only 4,500 years old, then they should be promoting the fact that they should have lots of biomolecules in them. And that's what they're doing, right? Things like what Matt Powell's doing right now is he's telling people, oh, lots of fossils have biomolecules present in them. But he's not telling them they're actually decayed, severely decayed biomolecules. All right? Completely modified biomolecules in a process that takes a long period of time. And the biomolecules that are left are in exceptionally stable molecular configurations compared to the original situation. Right? So the challenge today's challenge goes to Matt Powell to change this language. The next time he records the exact same video and tries to say the same thing, he needs to be more careful in his language. If he does, I'll apply to him. If he doesn't, we're going to be just right back here showing that he has yet to understand how to describe accurately the evidence that scientists have presented from these different sites. Great. I have one other analogy, right? I want to, because I think that some people might still say, well, look, I mean, They didn't find exactly hemoglobin, but clearly there was hemoglobin there, and that is actual pieces of the hemoglobin that are left. Like the atoms that are in that modified heme molecule, most of those atoms are probably the original atoms that were there. And so they're there, right? I mean, it's not completely inaccurate to say that there's hemoglobin there. All right, I would say the heme is there, but not the globin part. But okay, so there's hemoglobin there. I think that's similar to this. I think what young Earth creationists are doing is they're getting up in front of an audience and they're saying, like, what if I had a friend that said, hey, I found $1,000 bill while digging in my backyard, right? And they're all excited, right? I found $1,000 in my backyard. I found $1,000 bill. And you're like, fantastic. Like, what are we going to do? Where are we going to spend that? Where are we going to spend that money? Like, what are you going to save it? Or are you going to go splurge or something like that? And then your friend says, well, it's not really exactly $1,000. It's like, what it is I found this little tiny decayed scrap of material that in that scrap of material, I can see, I can point to enough evidence that this was part of a $1,000 bill sometime in the past, right? It's the last little tiny remains, the last bit that hasn't decayed. And it's really modified even, right? So whatever's percolated through here, it's combined with some iron and some other molecules that have bound to the material and maybe preventing it from being eaten by some insect, by a termite or something, right? All right, and I'm like, oh, that's not what I thought you meant. When you said you found $1,000 digging in your backyard, $1,000 bill, I pictured $1,000 bill. And this is what I think young Earth creationists are doing with their audience, right? They are using words that when the audience hears them, that conjures up in their minds pictures of red blood cells. In fact, they show red blood cells, pictures of living red blood cells on the screen in some cases. And so, of course, they're imagining, oh, that's what they found in that fossil. Hemoglobin. Oh, I've got hemoglobin in my blood. It transfers oxygen around. A lot of people know that, even if they're not biologists. Though it's got that protein. Well, that's a really big, complex protein, right? How could that have possibly survived? And so if the young Earth creationist speaker or writer, right, or YouTuber is saying these words, and they know what the audience is thinking when they hear those words, and they know that's not actually what was found, then they're lying to their audience, right? They're putting a belief in the heads of their audience that isn't true, right? They're leading them on. And so what I'm asking for is some truth telling, all right? Some accurate reporting, right? Try to work with that evidence to make your story and your case, but at least get your facts right. Otherwise, you're telling people that you are going to give them $1 million and then they get all excited. And what you actually hand them in the end is a pile of dust. And you say, like, yeah, here's the remains of that $1 million after I put it through a blender. Aren't you excited about this? No. And that's what's going to happen if some audience members actually dig into the data and say, I was led to believe this, and now I've just discovered that's not really quite accurate. It's going to make them start to doubt that particular speaker. And that's really what's like in my heart. I don't want people to be deceived. I want them to be able to have confidence in the facts and the evidence that they hear. All right. So that's it for me. That's the hemoglobin challenge. And so let me know if you run across a young Earth creationist who is claiming hemoglobin is found in dinosaur bones without qualifying exactly what the nature of that hemoglobin is, right? And we'll take it up and I'll follow up on it. Thank you very much. Have a great evening. We'll talk to you later. Bye-bye.